Good morning, ladies and gentlemen. Welcome to section 3.5. Deals with linear equations and rates of change. So we're building on what we talked about in section 3.4, adding a new word for our addition step of our recursive routine. And you'll see that here in the vocabulary that you need to know. So we'll get right into some of our examples here. Make sure you get this vocab written down. Alrighty, so we're finding the rate of change. What that means is we are looking for the difference between these two values when we go from 0 to 1 or from 1 to 2 or 2 to 3 or something where the x values go up by 1. We're looking for how much the output values go up by or go down by each time. That's our addition step usually. In this case, it's from 26 to 14, which is a value of 12. If we check with 38 to 26, that's also 12. So our rate of change is 12. This is also known as our b value of our equation. So if we have our equation y equals a plus bx, that 12 here goes in for b. So we have y is equal to, we have this 12x here, and then we look back to our original problem. We're looking for where x is 0. In this case, when x is 0, y is 14. So that means our a value here is 14. So we have the equation y equals 14 plus 12x represents this table. Okay, so now we've done this a couple different times. We've done this for a couple different sections. Now they're going to start making things a little bit tougher for us. And what they're going to do is now they're not going to necessarily give us nice, great values for inputs and outputs. Okay, they're going to say that these represent a linear relationship, that everything's fine, and they just don't give us all of the values. So what we can do here is we have our x values and our y values. That's our inputs and outputs. So this is our ins, this is our outs. Okay, we have -3, we've got -2, we're missing -1, we're missing 0 and 1 and 2 and 3 and 4 and 5. We got 6 back in there again, okay? So what we've got to do here, in order for us to do what we need to do, because we need to write this in y equals a plus bx form. We don't know the a value yet. We don't know our b value yet. We got to find that out. So we've got -2.3 or 2.6, -1.3. We don't know these next values. The next value we know is 6, which is 9.1. So we're missing all of these values in between here. Okay, I'm looking for that value for sure to help myself out. To get my a value, we need to find the b value, and that's because we can find that from this table by looking at from -3 to -2. That's a difference of 1. So we look at how much these go up by. And if we see that this is going from -2.6 to -1.3, that's going up by, or changing by a positive 1.3, so that's our rate of change. We can then apply that 1.3 to this value as well, which means we're going to have 0. We add 1.3 again, which makes this 1.3, and then 2.6, and then 3.9, then 5.2, and then 6.5, and then we have 7.8, and then it gets us to this 9.1. So we see how that works. I'm adding 1.3 each time. So now because I know this value right here, because I know this value, I can now fill in my table, or now fill in my equation. So we know that y is equal to 1.3, that comes from right here, plus 1.3x, and that comes from right there. Okay, so just because we don't know the zero value right away doesn't mean we can't figure it out some way, somehow. Okay, now in this last example, let me show you a little trick here. In this last example, it goes, we have our x value, we have our y value, we've got -5, then it goes to -3, so it skips -4, and then -3, and then skips -2, goes to -1, skips 0, and goes to 1. Okay, so we've got -26.3, -21.5, oops, -21.5 goes in the other spot, -21.5 there. We got then -16.7, then our table continues down. So we're forgetting these values. All the other tables we've had values that were right next to each other and we could figure stuff out. Here we don't. But do we see how it goes up by 2 every single time? So it goes from -5 to -3, that's up by 2. Okay. When we subtract these two values or add these two values, it goes up by a positive 4.8 from -5 to -3. And from -3 to -1 goes up by a positive 4.8. And from -1 to 0, that goes up by 4.8 as well. So that means, because that goes up by 4.8 from -5 to -3, it goes up by half of that from here, okay? Because these two values then have to add up to that 4.8. So that means when we take 4.8, we can divide that by 2, which gives us 2.4. So now this value goes up by 2.4 each time, which would give us a, so that means this then turns out to be 2.4 each time and 2.4 each time, okay? And because of that, our value here is going to be -23.9, and then this is going to go up by 2.4, which is going to make this value right here a value of -19.1, and we continue on, and it makes this value here, this goes up by 2.4 each time, makes this value here a -14.3. So now that's the value we need here for our equation, and our equation is going to be y is equal to a -14.3 plus a 2.4x. Okay, so we've talked about finding the rate of change. That's how much each time it changes, going up one values of 1. We've discussed a couple different ways to find 0 if it doesn't give it to us. And now we've figured out that if it doesn't give us values that are right next to each other, we can figure out the difference of the values that it gives us, and then figure out the difference of the y values and divide that y value difference divided by the difference of the x values, and that'll give us our step or rate of change for one spot. Here's the try on your own problem. Given the table here on our screen, find the rate of change and the intercept value, and then write that into an equation. Make sure you are getting this done and completed into your notes, as well as what you have learned over the course of this video. As always, if you have questions, make sure you let me know, and have a good day.